Okay, the first standard we're going to cover in second semester covers indices. Now, indices in Cambridge language is just the word for exponents. So whenever you see the term indices on a Cambridge question or in your book or whatever, what it's referring to is exponents. Okay, there are some laws of indices, and then I'm going to show you, so I'm going to go over these laws sort of general, then I'm going to show you how you can remember them just by doing some simple things. So the laws of indices. So the first one is that if you have a to the n times a to the m, that's equal to a to the n plus m power. Okay, so if I'm multiplying two things together that have the exact same base, I can just add the exponents together. 2, if I'm dividing, so if I have a to the n divided by a to the m, that's equal to a to the n minus m power. So if I'm dividing, I just subtract. And then the third one, if I have a to the n and then to the m power, that's equal to a to the n times m power. Okay, so there's the three laws of indices. Let me just show you a couple of examples. So if I have 2 squared times 2 to the third, that will equal 2 to the fifth. If I have 2 to the third divided by 2 squared, that equals 2 to the 1 power. And if I have 2 squared to the third power, then that's going to equal 2 to the 6th. Okay, now the base always has to be the same for you to be able to add exponents together. All right, now let's say you forget one of these laws. What you always can do is write it out. So in my first example, I had 2 squared times 2 to the third. 2 squared times 2 to the third. Okay, well think back to what does 2 squared mean? 2 squared means 2 times 2. And then 2 to the third means 2 times 2 times 2. And when I multiply those two things together, I have 2 times 2 times 2 times 2 times 2, which is 2 to the fifth. Okay, contrast that as where I have 2 squared to the third power. Well, 2 squared means 2 times 2. And then I have that 3 times. So I have it there, and then another 2 times 2, and another 2 times 2. And when I multiply all those things together, I have 2 to the 6th. Okay, division is just as easy to see. If I have 2 cubed over 2 squared, on top I have 2 times 2 times 2, and on bottom I have 2 times 2. And remember, if these are all factorized, I can cancel factors. So those two cancel, and those two cancels, and I'm just left with 2 to the 1 power. If it's just the 1 power, we don't even write it up there. Okay? Those are the three laws of indices that you need to deal with. The problems in 7.1 and 7.2 all involve positive indices. Okay? When you get to section 7.3, then you're going to have to deal with both the zero index and negative indices. So let's talk about the zero index. Okay, and that one's easy. Anything to the 0 power is equal to 1. All right, now here's the reason why something to the 0 power is 1. Let's sort of work our way down to 0 and start with something like a to the third. a to the third would equal a times a times a. A squared would equal a times a. A to the 1 just equals an a. Now, some of you are tempted to say when we get down here and say, oh, a to the 0, that it would equal 0. But here's the thing. What are we taking away from each of these each time? We're just taking an a away, right? As this number goes down 1, we take away an a. So there's no a's here. I agree, there are 0 a's. But here's the thing. Up here, this was a times a times a, not times 0. This was a times a times a times 1. And this is a times 1. If these were all times 0, then they would all equal 0. And obviously they don't. So these are all times 1, times 1, times 1. So in this one, yeah, that last a goes away, but I still have a 1 there. Okay, so that's the 0 index. That's why everything to the 0 power is 1. Or if you want to, think of it like, remember how we've already seen how subtracting exponents work? So if I had a to the third over a to the third, right? If I just subtract the exponents, that's a to the 3 minus 3, which is a to the 0, right? Well, let's think of it the other way where I break these out. That's a times a times a all over a times a times a. And those things all cancel out. Well, if those things all cancel out, what that means is it reduces down to 1. Not down to 0, down to 1. So anything to the 0 power is 1. All right, let's go a step further and go to negative indices. All right, let's keep going down this chart right here on the, what's in the middle now. Okay, so notice here, as I kept going, what I was doing was dividing by an a, right? So all this divided by an a gets me this. And then this divided by an a gets me this. And this divided by an a gets me this. All right, so if I want to go down one more, a to the negative 1 power, I need to divide 1 by a. So it's 1 over a. All right, a to the negative 2 would equal 1 over a squared. All right, so I just keep dividing by it. It's 1 over whatever that thing is, and then you can turn it into a positive exponent. And another way to see this, right, let's think of it like our division. So if I had a to the third over a to the fourth, that would equal a to the negative 1. If I'm subtracting exponents, 3 minus 4 is negative 1. If I think of it the long way, a times a times a over a times a times a times a, right? Those cancel, those cancel, those cancel. This one is still left on the bottom. So what I have left is 1 over a. Okay, and then that's how negative exponents work. Okay, so your assignment for today, you're doing 7.1, 7.2, and 7.3. All of the problems in there. I know that's going to seem like a lot of problems, but these are actually very quick problems. And most of this should be review for you anyway, and it's something that you should be able to handle. And I will see you guys on Thursday.